All right, welcome back. We are in chapter 2, lesson 1 of Algebra 1 College Prep. Side note, I probably should have said this earlier. Don't freak out about the college prep up there. It just means that they're catching you up to a college level. Like, the next step is college. This isn't college. This is still high school level. It's just everything you'd need to know were you to go to college next year. Does that make sense? Okay. So, well, now we've got inequalities. Up till now, we've been working with equal sign, 3 equals 3, 2x equals 4, that kind of thing. Now, we're working with inequalities. 2 is less than 3. 3 is less than 7. 7 is less than 10. Right? Then you've also got 7 is greater than 4. 7 is greater than 3. 9 is greater than 2. These are your operative symbols. Greater than, less than. You've also got, once you start doing equations, well, inequalities, they're not called equations anymore. Greater than or equal to, less than or equal to. So like 2x is greater than or equal to 4, for example. You'd still balance across the sign, so you divide by 2 and divide by 2. X is greater than or equal to 4 divided by 2 is 2. So any number, including 2, that is greater than 2 would satisfy this inequality. So 2 works, but 3 also works. 4 also works. 5 also works, because those are greater than 2. So it can be greater than or equal to 2. Okay. To move on to their first example. Their first example, what they want to start off with is word problems, changing small word problems into an inequality. So theirs is 5 times the number m is less than 7. 5 times the number m, so we've got m, and 5 times it, right, means you put the 5 in front, so 5m is less than 7. Okay. Then if we wanted to solve it, we would divide by 5, we would divide by 5, we'd say m is less than 7/5. Okay. Three times the number n plus 5 is at least 16. 3 times the number n plus 5 is at least. That means it's got to be equal to. If it's at the least, it is equal to 16. Then it could be greater than. At least is greater than or equal to. That's the same thing. That's a key phrase. At least means greater than or equal to. Okay. Example 3. The quotient. Quotient means divide. The quotient of x and 8 is fewer than the sum of 4. The sum is plus sum of 4 and 2 times the same number x. That's how that one works out. They're not actually asking us to solve it, they just want us to to write the inequality out. Let's see here. Example 4, determine if x equals 7.5 is a solution to this inequality. 2x plus 1 is less than 10. We're going to minus 1, minus 1. 2x is less than 9. Divide by 2, divide by 2. 9 divided by 2 is, what's that? 8 divided by 2 is 4, so 9 divided by 2 is 4.5. X is less than 4.5. Is 7.5 equal to or less than 4.5? No. So, no, 7.5 is not a viable solution. Determine if x equals negative 2 is a solution to this inequality. X over 2 is greater than or equal to negative 1. X equals negative 2. So I'm going to multiply that. X is greater than or equal to negative 2. And they gave us x equals negative 2. Is equal than is an option. Or equal to is an option. So, yes, that is a viable solution. Aha, writing on a number line is next. So you know what a number line is, right? You've got the arrows pointing off into infinity on one side and the other side. Come on, what a crappy arrow that is. I'm going to put 0 in the middle. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay, if x is 1, you just put a dot over 1. If x is negative 3, you put a dot over negative 3, right? That's just what it is. If x can be more than one thing, as inequalities show us, then we would put a line to indicate how much they are. So if x is greater than 1, then we do it like that. It's all numbers greater than 1. And we do it with an open circle because it does not include 1. It can include 1.1, 1.2, 1.3, all the way up to 2, and then 3, and then 4, and then 5. But it cannot include actual 1. So we do an open circle. Now, if we closed in the circle, colored it in, then that would mean it does include 1. And it would be greater than or equal to 1. X could be less than 2, or negative 2. If it's less than negative 2, we have the open circle. If it's greater than 0, right, here's 0, greater than 0. Is that making sense? This is the way we denote it. It's an open circle if it's greater than or less than. It's an open circle. If it's greater than or equal to, less than or equal to, it's a closed circle. There you go. There's simple rules of how to write down a number line. Yeah, that does it for lesson 1.